Alright, we are still dividing unit fractions with whole numbers. Trying to find some patterns going on here. First problem, Harriet needs to solve the division problem shown at the right. Use the area model to help Harriet determine the quotient of each problem. Then complete A through C. Okay, so remember yesterday, we were drawing the whole first. Alright, so we need to separate it into thirds. So I'm going to make thirds this way. And then we need to separate it into 4 pieces. But let's look, because I don't know. If we did that, you need to see, I want you to see the thirds. They're not showing it, but I want you to see it. That's 1/3, right? But if you divide that 1/3 into 4 equal pieces, then you're just going to have this one piece shaded. Okay? Next, we have a half divided into 5 equal pieces. My pencil cup is in the way. Alright, so I want to divide it into a half. And then I need to divide it. So let's color that whole half so you can see what I'm talking about. The whole half is there. But I'm going to take this shape and divide it into 5 equal pieces, or close to equal. And then we're looking at just this one section because it's 1/2 of 5. Excuse me. 5 of 1/2. Okay? So the first question says, observe the number of rows and columns in the area models and describe how they relate to the values in the division problem. So in other words, the numbers in rows, how does that relate here? So you could say the denominator of the unit fraction is the number of columns and the whole number is the number of rows. What they're saying is there are 1, 2, 3 columns, and there are 1, 2, 3, 4 rows. Okay? So how can you determine the total number of pieces in each area model without counting the pieces? You could multiply that denominator of the unit fraction by the whole number. Well, let's check that. Is that true? So 3 times 4 is 12. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That works. So to solve 1/10 divided by 12, would you choose an area model or another method? Well, me personally, I would choose to multiply 10 by 12 to find the total number of pieces. Instead of having to draw I'm going to say of drawing a model with 120 pieces. Let's see, where can I fit that? I'm going to put it right here. 120 pieces. Okay? Alright, so let's take a few notes here. When dividing a unit fraction by a whole number, the quotient will always have a numerator of 1. Because it's a unit fraction. It's 1. The denominator of the quotient will be equal to the product of the whole number and the denominator. So let's practice this. So, on number 1, top number, it says, when multiplying, the quotient will always have the numerator of 1. Well, that's easy. So all of them is going to have a 1 in this case. So all we have to figure out is the bottom number. The denominator of the quotient will be equal to the product of the whole number and the denominator. So 9 times 8 is 72. 12 times 6 is 72. 10 times 52, 520. 2 times 24. Waiting. 48. 3 times 41. Let's work that out. Maybe we don't know off the top of our heads. That's 3. 4 times 3 is 12. So it's 123. Okay? Ooh, definitely don't know this one off the top of our heads. 35 times 11. So 35 times 11. That's 5 times 1 is 5 here. That's 3. Placeholder. 5, 3. And if I add them up, 5, 8, 3. So that's 385. Okay, let's see what we got on the next page. All right. Restate and represent the problem situation described below. Then mark statements A and B as true or false. If false, rewrite the statement correctly. Emmett put a total of 1/2 pound of mushrooms on 16 steak kebabs. He put the same amount of mushrooms on each steak kebab. How many pounds of mushrooms did Emmett put on each steak kebab? So, okay, he put a total of 1/2. So that's where we're starting. And then he put 16 mushrooms on 16 kebabs. So we have to figure out how many pounds of mushrooms he put on each steak kebab. Okay? So it says restate and represent. So let's restate. Emmett used 1/2 pound of mushrooms on 16 steak kebabs. So what do we need to do? I need to divide 1/2 by 16. The pounds of mushrooms on each steak kebab could be found by solving 16 by 1/2. No. We started out with 1/2 pound of mushrooms. So this is wrong. So let's rewrite it. 1/2 divided by 16. Okay? It was false. We corrected it. Emmett put 1/8 pound of mushrooms on each steak kebab. Well, if we use our rules a while ago, we know the top number is going to be a 1. But then you have to multiply 2 times 16. 2 times 16 is 32. So this is false. It's 1/32 pound of mushrooms. Okay? All right. Next. Corey, Marisol, and Ezra each wrote division problems shown below. Use the hints to correctly label each student's work. Ezra's problem has the largest quotient. Corey's quotient is smaller than 1 and 145. All right, so we're just going to have to solve them. Okay, let's just start out. We know the top number's 1. 6 times 25, that's like having 6 quarters. So that would be like $1.50, so it'd be 150. We know the top number's 1. 36 times 4, let's see. That's 24. That's 12, that's 144. All right, and we know the top number's 1 on this one. And 13 times 9, that's 7. Regroup my 2. That's 11, so that's 117. All right, so let's look here. Ezra's problem has the largest quotient. That's going to be Ezra. And then Corey's quotient is smaller than 1 and 45. 1 and 145ths. Whew, that's hard to say. So this one can't be it. It's going to have to be Corey over here. So this must be Marisol. Okay. The next 3 things here, we have to complete the sentence with sometimes, always, or never. So dividing a unit fraction by a whole number greater than or equal to 1 will result in a quotient that is larger than a unit fraction. Never. Dividing a whole number greater than or equal to 1 by a unit fraction will always result in a quotient that is larger than the whole number. Always. Dividing a unit fraction by a whole number greater than or equal to 1 will result in a quotient with a numerator of 1. Always. Okay, let's see what your independent practice is. On your independent practice, it says to solve the problem on card A and draw a line from the arrow on the card. I don't see an arrow, but the arrow should be here. Anyway, draw a line from on card A to its solution at the top corner in column 2. Then solve the corresponding problem and continue drawing lines showing the path of each card to its solution in the opposite column to end at card A. Alright, so it's going to be a lot of line drawing. Okay, so first off, we've got to solve. The first row of a parking lot is 1/12 mile wide. Each parking spot has the same width. How wide is each parking spot if there are 48 parking spots on the first row? So we got 48 parking spots. So that's 1/12. Each one's a 12th. There are 48 parking spots. Okay, so we're going to divide that by 48. And we are going to get 1 on top. I'm going to have to come over here and we're going to have to multiply 48 times 12. 16, carry 1, 8, 9. Placeholder, 8, 4. So that's 6. That's 17, 576. Alright, oops, here's 576. So I'm going to take this card and draw it to this box. Now I need to solve this one. Oops, didn't see it. 576. 576 went here. Now we're going to solve this one. So we know the top number is 1. So I need 35 times 4. That's 20. 12 plus 2 is 14. So it's 140. So this one goes here. And you keep going until everybody's got somewhere to go. Okay? That's all you have.